Good morning, boys. Today we are going to see exercise 3.7, problem number 2. So here condition is if a plus b plus c equal to 2s, prove that sine of small s minus a sine of s minus b plus sin s and sin s minus c equal to sin a sin b. So here I am going to use the formula product to sum directly here. See, if I look at that, we have two terms, sin s minus a and sin s minus b plus sin s minus b. We have two terms. In this first term, it seems like sin a into sin b format. Here, this whole bracket consider as a, this bracket consider as directly. I am going to apply this identity, sin a into sin b identity, which is minus 1 by 2 into cos a plus b minus cos a minus b. So here LHS side minus 1 by 2 into cos a plus b is cos of s minus a plus s minus b, then minus of cos a minus b s minus a. So minus of b is minus s plus b plus here also it is sin a sin b formula, the same formula. Here we have minus 1 by 2, so it will become minus 1 by 2 into sin a plus b, sorry, cos a plus b s plus s minus c minus cos a minus b is cos of s minus s plus c. So after that, minus 1 by 2 cos of, here we have a cancellation. No, we don't have a cancellation. It is 2s, s plus s, 2s minus of a plus b, s plus s minus of a plus b minus cos, here plus s minus x will be cancelled. It is minus a plus b, then minus 2 into cos of 2s minus c minus s minus s cancel, it is cos c. So now look at that, 2s minus a plus b. By using this, if you keep c as it is, it will be 2s minus, bring this ab this side, plus ab. This already we have done that in the previous problems. Instead of 2x we have 180 here, but same thing here we are going to do here. See here, minus 1 by 2 into cos of 2s minus a plus b, we can write as c. So cos c minus a plus b, keep it as it is, minus a plus b minus 1 by 2 into 2s minus c, 2s minus c. If you bring this side, it is 2s minus c. Instead of that, I can write cos of a plus b minus cos c. Now multiply the minus, minus 1 by 2 take commonly from both terms, it will be cos c minus cos of minus a plus b, minus 1 by 2 came out, so plus cos of a plus b minus just came out, so it will become minus cos c. Here, now we have a cancellation cos C minus cos C, it will be cancelled. You will get minus 1 by 2 into, minus is here, so I am just rearranging the terms, cos of A plus B minus cos of minus A plus B. So here we have a form of cos C plus cos D formula, 2 into cos of C plus D by 2, cos C minus D by 2. So I am going to use this identity here. Minus 1 by 2 into 2 into cos of, this formula, cos C minus cos D formula is minus 2 into sin of C plus D. What is C? A plus B plus, here minus A, so minus A plus B divided by 2 into sin of C minus D, A plus B minus, here minus will become plus A minus B whole divided by 2. So this can be, have a cancellation, minus 2, minus minus cancel, 2 cancel. So sin, here we have, this will be cancelled, sin B 2B by 2 into sin, here we have a cancellation in B, we have 2A by 2 cancel, here also 2 cancel. So we have sin A and sin B which is RHS side, hence proved. So by this we can complete question number 2. Next question number 3. Question number 3, if the condition is x plus y plus z equal to x, y, z, to prove 2x by 1 minus x square plus 2y by 1 minus y square plus 2z 1 minus z square equal to 2x by 1 minus x square into 2y by 1 minus y square into 2z by 1 minus z square. So here I am going to prove LHS equal to RHS. Here directly we want to prove this one. So here I am going to take some condition from the book. So condition, see here I am going to substitute some values for x, y and z. So here let me assume x equal to tan A, y equal to tan B and z equal to tan C. So this assumption I am going to take to solve this problem. So here the condition is given x plus y plus z equal to x, y, z. So here instead of x tan A plus tan y, tan B plus tan z, I mean tan C equal to tan A, tan B and tan C. So this I have getting by assume this x value, y value and z value by using this condition. But if you see this format, I mean this property, I can remember that if you see the book page number 108, in the bottom of the page is given the identity if A plus B plus C equal to 0 or pi, we can say this condition, tan A plus tan B plus tan C equal to tan A, tan B, tan C. This is we can take when you have A plus B plus C equal to 0 or pi. Here I am going to take A plus B plus C equal to 0. Here I am going to take, I am going to multiply throughout this one 2A plus 2B plus 2c equal to 0. So when you have a plus b plus c equal to 0, we can write tan a plus tan b plus tan c equal to tan a. This is given page number 108 in the book. The property is directly given in the book. You can refer the book in this property. In this case, we can say a plus b plus c equal to 0. Using this condition, I am going to take 2a plus 2b. I am just multiplying this with this condition. It will be 2a plus 2b plus 2c into 2 into 0, 0. So, in this condition, if 2a plus 2b plus 2c, what the identity will, what will happen to the identity? So, instead of a plus b plus c equal to 0, here a plus b plus c, here we have a, b and c. If you have a 2a, 2b, 2c, here we have a changes, the same condition, but we have changes in the angle value. So, here by this condition, by using this condition, we can change the identity, which is tan 2a plus tan 2b plus tan 2c equal to 2 tan 2a into tan 2b into tan 2c, which is 1. Take that is 1. So, by this condition, we can say tan a plus tan b plus tan equal to tan a, tan b, tan c. But by this condition, we can say tan 2a plus tan 2b plus tan 2c equal to tan 2a into tan 2b into tan 2c. Using this condition, you just keep it as it. Then next, we just go for the first left hand side to prove right hand side. Just you have it as the equation 1 for reference. Let me take LHS side. 2 into, instead of x, already we have assumed x as tan a, isn't it? Tan a by 1 minus tan square a plus 2 y as tan b, we have assumed 1 minus tan square b plus 2 into z as tan c by 1 minus tan square c. See, look at here. See, this is the form of, we know the formula, we have identity. Tan 2a identity is 2 tan a by 1 minus tan square a. This identity we know that, already we have learned this identity. This identity, I am going to use this identity because the form of, the identity is here. So, instead of this, I can write tan 2a plus here tan 2b plus here tan 2c. So, using this identity, so I am getting this left hand side proof. So, I told you already we have this proof. If you have left hand side proof, directly we can write right hand side. So, tan a plus tan b, tan 2a plus tan 2b plus tan 2c can be written as tan 2a, tan 2b, tan 2c. Tan 2a into tan 2b into tan 2c. So, tan 2a plus tan 2b plus tan 2c can be written as tan 2a, tan 2b and tan 2c. So, this once again by using equation 1. Okay, now I have to bring this values, 2x by 1 minus x. Okay, anyway. So, tan 2a can be written as 2 tan a by 1 minus tan square a by using identity. Tan 2b, 2 tan b by 1 minus tan square b into tan 2c, 2 tan c divided by 1 minus tan square c. After that, we have taken tan A as x, tan B as y, tan C as y. Next, I am just rearrange once again. 2 tan A instead of that x by 1 minus x square into 2 tan B is written as y, 1 minus y square into 2 tan C as z, 1 minus z square, which is RHS side, hence proved. So by this we can complete the problem number 3. Next, problem number 4. Problem number 4, if a plus b plus c equal to pi by 2, I mean 190, prove that we have a 2 subdivision. First subdivision I will do it, second one you have to do it, because it is same model, you can do your own. So first subdivision I will do it for you. Sin 2a plus sin 2b plus sin 2c equal to 4 cos A cos B cos C. So already we have done like this problem in the question number 1, some subdivisions, but here the condition was given a plus b plus c is equal to 180, but here is given a plus b plus c is equal to pi by 2, I mean 90. So here LHS, I am going to take LHS side. Sin 2a plus sin 2b, here I am going to take the formula sin c plus sin d formula, sum to product sin c plus sin d formula, which is 2 sin c plus d by 2 cos c minus d by 2. So here this c, this is d, 2 sin 2a plus 2b, here I can take 2 commonly outside, plus b by 2 into cos of c minus d. Here c minus d is 2 into a minus b by 2 plus sin 2c, keep it as it is. Okay, now 2 will be cancelled, here also will be cancelled. So 2 into sin a plus b plus c equal to 90 degrees given. So a plus b equal to 90 minus c we can write. So instead of a plus b I am going to write 90 minus c into cos of a minus b as it is plus sin 2z as it is. Next, 2 into 90 minus, which is first quadrant, there is no sign changes. Next, 90 instead of 90, we have to change the ratio sign into cos c into cos of a minus b plus sin 2c, sin 2 theta, very familiar formula, very important formula already. We know that sin 2 theta can be written as 2 sin theta cos theta. So this formula I am going to use here. So sin 2c can be written as 2 sin c cos c. Here we can take 2 cos c commonly outside, remaining cos of a minus b this side. In this term we have taken 2 cos c came out, only sin c is remaining. Now 2 cos of c cos of a minus b plus sin c, instead of c I can write c equal to, keep this c this side, bring a plus b to other side, it will be minus a plus b. So 90 minus a plus b. So instead of c I can write 90 minus a plus b, 90 minus a plus b, you have to write it in the bracket. Okay, now next step is 2 cos c as it is into cos of a minus b plus sin 90 minus, which is first quadrant, there is no sign changes. Because of 90 we have to change it into cos A plus B. So here we have a cos D plus cos D, sorry, cos C plus cos D formula. Third one, 2 cos C plus D by 2 into cos C minus D by 2. So 2 cos C plus D A minus B plus A plus B by 2 into cos C minus D A minus B minus A minus B by 2. So here 2 cos C, 2 into cos of minus B plus B cancel, 2A by 2 into cos, here A and minus A cancel, minus 2B by 2. 2 cos C into, here 2 cancel, here this 2 and numerator 2 cancel. So 2 into cos of A, here cos of minus B will be cos B, positive. So multiply inside the bracket, 2 into 2, 4 cos A, cos B and cos C, which is RHS side. Hence proved. If you see the second subdivision, it is given cos 2A, instead of sin 2A it is given cos 2A, cos 2B and cos 2C. So here we have to use cos C plus cos D formula for next subdivision. This subdivision is over. Next subdivision, same method, same formula, cos C plus cos D formula. This formula we have to use it instead of here. In this first LHS side we have to use this, and then next one third term we have to change according to the common factor which was taken here. So using that one we have to change in the third term and we will get the answer. All this depending in this product to sum and sum to product formulas. So second one you can do your own. Next, problem number 5. Problem number 5. First question is, first subdivision. Before that, the condition is given: if ABC, triangle ABC is right triangle, angle A is given, this is 90 degree, prove that. First question, cos square B plus cos square C equal to 1. First one, I am going to take LHS side. Cos square B plus cos square C. Before that, using this condition, we know that I am going to take a right angle triangle diagram. This is A, B and C. Here angle A is 90 degree. Using this diagram, I am going to solve this problem. First LHS side, cos square B. When you angle B, when you take angle as B, cos is adjacent by hypotenuse. Cos is adjacent by hypotenuse, that is AB by BC whole square, because we have a cos square, plus cos square C. When you take angle C, here when you take angle C, what is the cos function? This is adjacent by hypotenuse. Adjacent by hypotenuse, it is AC by BC whole square. This is next. Common denominator is BC square AB square plus AC square. Here by Pythagoras theorem we know that AC square plus AB square equal to BC square. AB square plus AC square equal to BC square. We know that by Pythagoras theorem AC square plus AB square can be written as BC square. So AB square plus AC square can be written as BC square by BC square. So both are same. So if you cancel it, you will get 1, which is right hand side. Hence proved. Once again I will explain this problem. Cos square B plus cos square C. So here directly given angle A is 90 degree. So cos square B. So if you take angle B, if you take angle as B, if it is theta here, what is the cos function? Adjacent by hypotenuse. Adjacent is AB side, hypotenuse is BC side. So adjacent by hypotenuse. Cos square C. C as theta value. Cos function is adjacent. Here adjacent is this one, hypotenuse this one. So adjacent is AC by BC. So whole square. So after that, using Pythagoras theorem, numerator also will be BC square. So after cancellation, you will get 1, which is right hand side. The second question is sin square B plus sin square C. Same like last problem. LHS side A as 90 degree, A as 90 degree. Here sin square B. If you take B as a theta, what is sin? Sin is opposite by adjacent. So it is AC by BC whole square plus C as a theta. What is sin function? Opposite by hypotenuse. Opposite side is AB. AB by BC whole square. Now common denominator is BC square. Numerator AC square plus BC square. We know that AC square plus AC square plus AB square. So AC square plus AB square, we know that BC square. BC square by BC square, cancellation 1 equal to RHS side. Hence proved. So problem number 5, third subdivision. Cos B minus cos C equal to minus 1 plus 2 into root of 2 cos B by 2 sin C by 2. Here I am going to take LHS side. If you want to do this problem, so many things we have to remember, otherwise we can't able to do the problem. Here cos LHS side, cos B minus cos C. Here answer we have to bring it in the B by 2 and C by 2. It's half angle in the answer. So here we have to use half angle formula for left hand side first. So cos B, we have a cos 2B can be written as 2 cos square B minus 1. 2 cos square B minus 1 formula. We have, I told you already, we have 4 formulas here. I am going to use this formula for cos 2B. So if you want to find out half angle formula for cos B, if you reduce half from this angle, the opposite side will be cos square B by 2 minus 1. This is the half angle formula for cos B. So using this formula, first I am going to write this one, 2 instead of cos B, 2 cos square B by 2 minus 1 minus cos C. This is LHS side. So because why I am using this formula? Sir, what is the purpose of using this formula, sir? Here in the answer I have 1, minus 1. Isn't it? We have minus 1. So, if you use this formula, we will get minus 1. That's why I am using this formula. So, we have another formula 1 minus 2 sine square b by 2 also we have, but I am not using this formula because I need a minus 1 in the right hand side. So, if you use this formula, we can get minus 1 in the right hand side. So, that's why I am using that formula. So, minus cos c. Next, minus 1 I am bringing this side, plus 2 cos square b by 2. So, here cos c, here already the condition is given, it is a right angle triangle. So, sum of the angles equal to 180 degree. We know this by given information because ABC or right angle triangle. So, sum of the angle is 180 degree. Here A is already is given, it is 90 degree plus B plus C equal to 180 degree. So, B plus C 90, if you bring this side minus 90. So, 180 minus 90 it is 90. So, C is equal to 90 minus B. 90 minus B. So, cos 90 minus B minus 1 plus 2 cos square B by 2 minus cos 90 which is first quadrant. 90 minus theta is first quadrant, no sign changes. Since we have a 90, we have to change the ratio cos into sin B. Next, minus 1 plus 2 cos square B by 2 minus sin B, half angle. Sin B can be in the half angle formula 2 sin B by 2 cos B by 2. Half angle formula. Sin 2 sin B by 2 cos B by 2. So, sin B can be written as 2 sin B by 2 cos B by 2. So, here minus 1 as it is. In this 2 term, I am going to take 2 cos B by 2 commonly outside. So, 2 cos B by 2 I am taking outside. The remaining is cos B by 2 minus 2 came out, cos B by 2 came out. We have only sin B by 2. Sir, look at the bracket. We have cos B by 2 minus sin B by 2. It is a sum to product identity, but we have only sin C sin D, sin C sin D, cos C plus cos D, cos C minus cos D. Here there is no interchange in the ratio. So here, but here we have a cos C minus cos sin D. Here we need a cos function, not sin function. So I am going to change into cos function. How can we change into cos function? We know this. Cos of 90 minus theta, we can write sin theta. Am I correct? Cos 90 minus theta, it is cos 90 minus theta, we can write 90 minus theta, we can write, look at that, cos 90 minus theta, we can write sin theta, because cos 90 minus theta is what? Cos 90 minus theta is first quadrant, there is no sign changes. 90 instead of 90, sorry, since 90 we have to change the function cos into sin. So sin theta. So sin theta can be written as cos of 90 minus theta. So here what is the cos 90 minus here 1 minus 1 plus 2 cos P by 2 into, before that, before change this function, look at that, cos B by 2, in the answer we have cos B by 2, sin C by 2 is coming, isn't it? Here we have a B by 2 already is there. So in this bracket value we are supposed to bring sin C by 2. So here what is there? Here we have a B. So I have to change B into C. How can we change it? B into C. So instead of B, by terms of C, I can write B equal to 90 minus C. I can write 90 minus C. Now, cos 90 minus C, which is 90 minus C, which is we can write in the radian form. It will be easy. Pi by 2 minus C by 2 minus sine of pi by 2 minus C by 2. Correct. Okay, now minus 1 plus 2 cos B by 2 as it is. Bring this denominator down or split the denominator in the numerator will be cos pi by 4 minus C by 2. This is 1 and then minus sine pi by 4 minus C by 2. Now minus 1 plus 2 cos B by 2. Now I told you know that cos of 90 minus theta sin theta, because why I am writing this? We have a formula cos C minus cos D. Here cos C minus, here it's supposed to be cos, not sin, if you want to use the identity. So I have to change sin into cos. Here this bracket as I am going to consider as theta. This whole bracket I am going to consider as theta. If you want to sin theta to change into cos, it will be cos of 90 minus theta. So cos of 90 minus theta, before that cos pi by 4 minus C by 2 minus cos of, I have changed cos sin into cos, but when you have changed pi by 2 minus of pi by 4 minus C. I mean, listen carefully. This is, I am just changing cos theta, sin theta into cos of 90 minus theta. This whole thing is considered as theta, 90 minus theta. So this, don't be confusing here, it is 90 minus theta. So sin theta can be written as cos of 90 minus theta, because we have to use cos C minus cos D formula, cos C minus cos D formula. Next minus 1 plus 2 cos B by 2 cos of pi by 4 minus C by 2 minus cos of, multiply inside, pi by 2 minus pi by 4 plus C by 2. Minus 1 2 cos of B by 2 cos pi by 4 minus C by 2 minus cos of, it is common denominator is 4, 2 into 2, 2 in numerator, 2 in denominator. So 2 pi minus pi 4 plus C by 2. Now we have getting cos C plus minus cos D formula. Here I can use cos C minus cos D formula. Here minus 1 plus 2 cos of B by 2 into cos C minus cos D formula is minus 2 sin C plus D by 2 sin C minus D by 2, minus 2 sin C plus D by 2, C pi by 4 plus, pi by 4 minus C by 2 plus pi by 4 plus C by 2 whole divided by 2 into sine of C minus D. C is pi by 4 minus C by 2 minus of this one, directly I can multiply minus pi by 4 minus C by 2 whole divided by 2. Don't make mistake here. You have to be very careful when you apply the identities such like these cases. Okay. Now minus 1 plus 2 cos b by 2 minus 2 sin, here minus c by 2 plus c by 2 cancel, pi by 4 plus pi by 4, 2 pi by 4 whole divided by 2, 2 cancel, sin of, here we have a cancel, plus pi by 4 minus pi by 4, minus 2c by 2 by 2 cancel. So here minus 1 plus 2 cos of b by 2 minus 2 sin pi by 4 into sin of c by minus c by 2. Here minus sign of negative will be whole function will be negative. So bring this minus outside, already we have minus, so it will become positive. Minus 1 plus 2 cos b by 2, so it is become positive. Sin pi by 4 value is 1 by root 2 into sin c by 2. So if I cancel this, this is root 2 minus 1 plus multiply all these values, 2 into root 2, 2 root 2 cos b by 2 and sin c by 2, which is RHS side. Hence proved. So by this we can complete problem number 5 in the last problem in exercise 3.7. So today we are going to complete the classes. The next exercise we will see in the next class. Thank you.